Hello and welcome to the lesson on adding and subtracting fractions. This is another video as part of our Functional Skills Level 1 and Level 2 course. The learning outcome is to add and subtract quantities using proper and improper fractions and mixed numbers. This links to previous learning where we learnt that fractions can be equivalent. So if we had our piece of pizza and we cut it into 8 pieces, we were interested in 4 of the 8 pieces, it's exactly the same as half a pizza. Because if we multiply the top and the bottom of our original fraction by the same number, we end up with an equivalent fraction. So 4 over 8 is exactly the same as a half. It's just another way of writing it. And that's the secret behind adding and subtracting fractions. So linking it to something we did in a previous lesson, let's have a look at comparing fractions. So let's see which of these fractions is bigger. Now remember how to do this. The denominator needs to be the same so we can compare like with like. So we're looking for a number that both 5 and 7 divide into. In other words, that they are factors for. Now the lowest number you can come up with is 35 because 7 5s are 35. Now to get from 5 to 35, I've multiplied the denominator by 7. So I have to do the same for the numerator to make it equivalent. So it becomes 14 over 35. If we do the same for this fraction, where I multiply 7 by 5 to get my 35, then I need to do the same with the 3 to get 15 over 35. So as equivalent fractions, we can see that 3 over 7 is bigger than 2 over 5. Now, if we remove some of this working out, can you see that if we just put a plus sign between them, so this ability to produce equivalent fractions, if we just stick a plus sign in between them, then they have the 35 as the denominator and 15 plus 14 is 29. So doing equivalence allows us to add and subtract fractions as well as compare them like we did in a previous lesson. Now, some of you may already be familiar with adding simple fractions like a half, a quarter and 3/4, and this is because of time, and you're used to doing this with times. So if I said to you add a half and a quarter, you would say 3/4. You'd think of half an hour added to another quarter of an hour, and that would give you 3/4 of an hour. So some questions you can actually do by using the clock system if the numbers are nice, easy halves and quarters, and they will test you on this with time. So how do we add and subtract other fractions? Well, providing the denominator is the same, we can make the denominator that number, and then we're allowed to add the 1 to the 2 to get 3 over 5 as the correct answer for 1/5 plus 2/5. So if the denominator is the same, add the numerators together, but keep your denominator. If the denominators are different, you're not allowed to add them straight away. You have to make sure they share a common denominator. So this brings us back to equivalence. We're looking for a number that both 3 and 5 divide into, and the lowest number I can think of is 15. So when we add these two numbers together, our denominator is going to be 15. Now the first question is, how did I get from 3 to 15? Well, I multiplied it by 5. So we now understand to keep 1/3 the same and make it equivalent, I have to multiply the numerator by 5. So 5 over 15 is the same as 1/3. It's just written in a different way. Now let's look at 2/5. I want to make the denominator 15, so I have to multiply the 5 by 3. And whatever I do to the denominator, I have to do to the numerator. So 2 times 3 gives me 6. So 2/5 is the same fraction as 6/15. But now, because they share the common denominator, that denominator makes up my answer, and I can add 5 and 6 to get 11. Can you see how that works? Good. Have a go at these fractions that are being added together. So as we've just seen, 3 and 5 have a common denominator of 15. How do I get from 3 to 15? I multiply by 5, multiply the numerator by 5, and 5/15 is the same as 1/3. Now for the 5. How did I get from 5 to 15? Well, I multiplied by 3, and what I do to the denominator, I have to do to the numerator. So 3/15 is the same fraction as 1/5, just written in a different way. So when you add your fractions, the denominators need to be the same to give you your common denominator, 15. And now I can just add the 5 and the 3 to get 8. So 1/3 plus 1/5 is 8/15. Let's have a look at the next one then. We have 2 and 7, so we're looking for a number that is common to 2 and 7, which is 14. To get from 7 to 14, I multiplied by 2, therefore I need to multiply my numerator by 2 to give me 4 over 14. To get from 2 to 14, I multiplied it by 7, therefore I multiply the numerator by 7, so 7 over 14 is the same fraction as 1/2. Because they have a common denominator, that's the denominator for my answer, 7 plus 4 is 11. Final question, 3 and 7, looking for the lowest common denominator, it's 21. 3 goes into 21, so how did I get from 3 to 21? I multiplied by 7, do the same for the numerator, and you end up with 14 over 21. How did I get from 7 to 21? Well, I multiplied it by 3, so do the same to the top, and I end up with 9 over 21 is equivalent to 3/7. The common denominator is 21, and I add the 14 to the 19 to get 23. Do you remember what sort of fraction this is? Good. It's an improper fraction. It's top heavy. You can leave it like this if the question doesn't tell you to change it, but it can be changed to a mixed number. Do you remember how to do that? Divide the numerator by the denominator, so I know 21 goes into 23 once, and there's a remainder of 2, and the 2 still needs to be divided by the 21. So 23 over 21 can be written, if we want, as 1 and 2 over 21. Subtraction is no different at all. If you have the same denominator, then if that's your common denominator, that's going to be the denominator for your answer. Then all we need to do is take the 1 away from the 4 to give us 3. If you don't have the same denominator, you have to look for the lowest common denominator. So you're looking for a number that both 7 and 2 divide into, which is 14. So how many times does 7 go into 14? Well, we've multiplied it by 2. So we do the same to the numerator. So it's 10 over 14 is the same fraction as 5 over 7. Do the same with a half. How did I get from 2 to 14? I multiplied it by 7. Do the same for the numerator, and I end up with 7 over 14 as an equivalent fraction for a half. 14 is our common denominator and the denominator for our answer. And now all we do is take 7 away from 10 and we end up with 3. So our answer is 3 over 14. Here are 3 subtractions of fractions for you to have a go at. Okay, let's go through the answers. So we're looking for a common denominator, a number that 4 and 10 go into. And the lowest one I can think of is 20. As 4 goes into 20 5 times, I've multiplied 4 by 5 to get 20. I multiply the numerator 3 by 5 to get 15. So 3/4 is 15 over 20. To get from 10 to 20, I've multiplied by 2. Therefore, I multiply the numerator by 2 to get 6. So 6 over 20 is the same fraction as 3 over 10. Now we do the maths. 15 take away 6 is 9, and our common denominator is 20. So the answer is 9 over 20. Let's look at the next question. We have 11 and 4 as our denominators, and we need to find a common denominator for them. So the lowest number I can think of that they both go into is 44. And this is a subtraction question. To get from 11 to 44, I multiplied by 4. Multiply my numerator by 4, and I end up with 24 over 44. To get from 4 to 44, I multiplied by 11. Multiply my numerator by 11, and 11 over 44 is the same fraction as a quarter. But now they have the same denominator. So our common denominator for our answer is 44, and 24 minus 11 is 13. So the answer is 13 over 44. Now the fractions we've had so far don't simplify, but when you do this subtraction, you should always look at your fractions to see if they simplify. Let's look at the last question. Again, we've got 3/4 minus 5/11. So 4 and 11 are our two denominators. So we need to find something common to both of them, which we've just done, which is 44. They both go into 44. How did I get from 4 to 44? I multiplied by 11. So I multiply the 3 by 11. So 33 over 44 is the same as 3/4. Look at the other denominator, 11. I multiplied it by 4 to get 44. So I need to multiply the numerator 5 by 4 to get 20. Take them away. 33 take away 20 is 13 over 44. Do they simplify? No, they don't. Something else to be aware of is subtracting from 1. When we add to 1, people don't have issues. If I said 1 plus a half, you'd say 1 1/2. But when we're taking numbers away from 1, people get a bit confused. So if you have something, for example, like 1 take away 1/5, then 1 is actually the same as 5/5. We can make the denominators the same. So 1 can be 5 over 5, it can be 7 over 7, 12 over 12. It doesn't matter. If the numerators and the denominators are the same, the number we have is the number 1. So here I want a denominator of 5. So the number 1 is actually 5 over 5, because 5 divided by 5 gives me 1. Now you can see our common denominator of 5, and 5 take away the 1 leaves you with 4. So when you have things like probability that we'll come on to later in the course, where probability adds up to 1, if the probability of something happening is 1/5, then what's left is 4/5. So if you have something is going to happen is 2/3, then what's left is 1/3. So these two numbers add up together to give you your denominator. These two numbers add up together to give you your denominator. Let's have a look at a question from a practice paper. If 1/3 of quality streets are toffee and 1/4 are chocolate, what fraction are left? So there are two elements to this question. We have 1/4 and 1/3 that we need to add together to work out the total of the toffee and the chocolate. So we have 1/3 is toffee plus 1/4. Now we can't do this because they don't share a denominator, so we have to find something that's common to them. So that's the number 12. 3 goes into 12 by multiplying it by 4, so we do the same to the numerator. So 4 over 12 is equivalent to 1/3. If we do the same for the 4, 12 divided by 4 is 3, so multiply the numerator by 3. 3 over 12 is the same as 1/4. Add the two together using our common denominator, so 4 plus 3 is 7. So 1/3 plus 1/4 is 7 over 12, and that's the first part of the question. What it's saying is, what fraction of the quality streets are left? So what it's saying is, if I've got 1 of something and I take away 7/12, what's left? So we're looking for a number that we add to 7 that gives us our total of 12, and that's 5. So 1 take away 7/12 is 5/12. So these two numbers added together give you the 12 that matches the denominator. So here's another exam style question. This comes from a practice paper, and Alex, Jas and Steph each get a student loan to help with living expenses. They decide to allocate 2/5 of their loans for food, so 2/5 is on food, and 1/6 for travel, 1/6 for travel. And it's asking what fraction of their student loan will be left to spend. So once they've paid for the food and the travel, what have we got left? Much like the last question, we need to add together the things that they have. So we have 2/5 plus 1/6 to work out what they've spent on food and travel. You need to find a common denominator. You can't just add these as they are. You need to find something that they both go into. And the common denominator is 30. To get from 5 to 30, I multiplied it by 6. Do the same to my numerator and you end up with 12 over 30. So 12 over 30 is equivalent to 2 over 5. Do the same with your denominator of 6, where you've multiplied that by 5. You have to do the same to the numerator, multiply it by 5, and you end up with 5 over 30. So the fraction 5 over 30 is equivalent to 1/6. Now we have a common denominator. That common denominator is our denominator for our answer. And we can just add the 12 and the 5 to get 17. So the answer to the first bit of how much they spend altogether for food and travel is 17/30. But that's not what the question's asking. It's what have they got left? So if 1 is everything, we have to take away 17/30 from 1. To do this, we're looking for the number we add to 17 to make 30. So it's 13. So what's left is 13/30, because 17/30 is spent on food and travel. Therefore, 1 take away 17/30 leaves 13/30. Again, take a look at all of your fractions to see if they can simplify. And in this case, they can't. In functional skills, they're very keen on adding and subtracting mixed numbers. And this is because of time. So if you've got an appointment in an hour and a half, what time do you need to set off? If I leave the bus stop now, what time will I get into town if it takes an hour and a quarter? It's those kind of questions that this refers to. So let's have a look at these two questions, but using common sense and our knowledge of clocks. So if I had to add 2¼ hours plus 1½ hours, I can add the hours together to get 3 hours. So you can add the whole numbers. And then if I've got a half an hour and I add a quarter of an hour, I know I've got 3/4 of an hour. The same for subtraction. If I've got 4¾ of an hour and I have to take away 2½ hours, then 4 take away the 2 leaves me with 2 whole hours. And if I've got 3/4 of an hour and I wind the clock back half an hour, it leaves me with 1/4 of an hour. So you can actually do some of these more basic fractions as clock times. And here's some examples from functional skills type questions on this very thing. 3 TV programs last for 1½ hours, 3/4 of an hour, and 1 3/4 hours. If I watch them all, how long would this take? Now, because there are several stages to this, the best way to show calculations with time is do some chunking. So if we start off with 1½ hours, and we know that we've got to add this 3/4 of an hour, so if I take half an hour from that 3/4 of an hour, it takes me nicely to 2 hours. But don't forget the quarter that I had left over, so 2¼ hours to add that 3/4 of an hour. Then, if I've got to add 1 3/4 hours, add the 1 hour first to give me 3¼ hours, and then add the 3/4. So 1/4 plus 3/4 gives me another whole number, which is 4. So how long would this take? 4 hours. The next question. Next question. A girl walks to the shops. It takes her half an hour to get there. She shops for 3/4 of an hour, and it takes her 3/4 of an hour to get back. Let's have a look at the next question. A girl walks to the shops. It takes her half an hour to get there. She shops for 3¼ hours, and it takes her 3/4 of an hour to get back. How long did the shopping trip take? So we start off with our half an hour, and the first thing we can do and add is the 3 from our 3¼ hours. So I'm going to add 3 hours. So I've got 3½ hours now. I can then add my quarter that I had left over. So add my 1/4 of an hour, brings me to 3 3/4 of an hour. It then takes her 3/4 of an hour to walk back. So if I just start off with a 1/4 of an hour to make it a nice round number as 4, and I take a 1/4 of an hour off 3/4, it leaves me with half an hour to add at the end. So the shopping trip takes 4½ hours. And notice the step method or the chunking method by which we did this. With the new reformed maths, they can just ask you outright to add 2 mixed numbers. So here we have 3 1/3 plus 2 2/5. Now, much like our time, I would add the 2 whole numbers first. So 3 plus 2 means I have 5 as a whole number. And then go away and add your fractions. Now, you can't add a third to a fifth, so we need a common denominator. So the number that 3 and 5 both divide into is 15. You know to get from 3 to 15, you've multiplied by 5. So multiply your numerator by 5. So 5 over 15 is the same as 1/3. For your 2/5, to get from 5 to 15, you multiplied it by 3. Do the same to your numerator. So 2 times 3 gives you 6. So the sum of your 2 fractions is 11/15. So you've done your whole numbers, 5 and your fractions add up to 11/15, and this is the correct answer. Now sometimes when you add your fractions together, it gives you a total bigger than 1. It'll give you an improper fraction. All you need to do is turn it into a mixed number and add the whole number to the whole number you've already got. Let me show you with this example. We've got 1 3/4 plus 2 5/6. So we add the two whole numbers together to get 3, and that's done. What we need to do now is add the 3/4 and the 5/6. So we need a common denominator for them. And the lowest number that 4 and 6 both go into is 12. So to get from 4 to 12, I've multiplied by 3. Multiply the numerator by 3, and 9/12 is the same fraction as 3/4. So to get from 6 to 12, I've multiplied it by 2. So I need to do the same for my numerator. So 10/12 is the same fraction as 5/6. Now, when I add them together, I end up with 19/12, an improper fraction. And this is where the skills we learnt earlier come into effect. If you divide the 19 by 12, it goes in 1 full time, remainder 7. So you're left with 7/12. Now you had 3 whole numbers over here, but you've got another 1 here to add. So your answer is going to be 4 7/12. Here are 3 mixed number additions for you to have a go at. I'll give you a couple of minutes and then I'll rapidly go through the answers and show you my working out. Don't forget to pause the video if you need more time. Okay, let's go through the answers. 6 plus 2 is 8, so I need to add a half and a third. The common denominator is 6, and 2 to 6 is 3, times the 1 is 3. 3 goes into 6 twice, multiplied by the numerator gives me 2/6. Add them both together and I end up with 5/6. So the answer is 8 5/6. Here we add the whole numbers to get 10, but we need to add the 3 and the 4, and the common denominator is 12. 3 to 12 I've multiplied by 4, so 2 times the 4 is 8. 4 to 12 I've multiplied by 3, times the 1 is 3. So your whole number is 10 and your fraction is 11/12. Last question, 9 plus 3 is 13. Here I need to add 3/5 and 2/3. So the number they both have in common is 15. To get from 5 to 15, I've multiplied by 3, multiplied my numerator by 3, so 9/15 is the same as 3/5. To get from 3 to 15, I multiplied by 5, do that to the numerator, I end up with 10/15. So add the two together and I end up with 19/15. Turn it from an improper fraction into a mixed number, so 15 divides into 19 once, remainder 4, and it still needs to be divided by 15. You've got 13 whole numbers here, plus the one that you've just created, so your answer is 14 4/15. Did you get those? Now let's do subtraction. Exactly the same as adding mixed numbers, do the whole numbers first and then do the fractions. So 3 take away 1 is 2, and I need to subtract 3/4 and 1/6. So we need to find a common denominator. So the first number that 4 and 6 can both divide into is 12. To get from 4 to 12, I've multiplied by 3. Do the same to the numerator, so my equivalent fraction is 9/12 4 3/4. We do the same for 1/6. 6 goes into 12 twice, so multiply the numerator by 2, and 2 over 12 is equivalent to 1/6. Now we have a common denominator. That gives us our denominator for our answer, and 9 take away 2 is 7. So our answer, our whole number, is 2, and our fraction is 7 over 12. So 2 and 7 over 12. Much like our addition problem earlier, where you can have a mixed number as an answer, with subtraction you could end up with a negative number for an answer. So let's do the whole numbers first, where 6 take away 2 is 4. Now we're left with the fractions to do. So I've got 1/5 take away 2/3. Now, the common denominator for 5 and 3 is 15. It's the lowest number they both divide into. Now 5 into 15 goes 3 times, so multiply the numerator by 3, and then 3 divided into 15, you multiplied it by 5 times, do the same to the numerator, and you end up with 10. Now if you notice, the smaller number is first, but we still have to do the maths, so remember what we told you on negative numbers. If you're at the number 3 and you're going to take 10 away, you end up at -7. So your answer is -7/15. So what you have to do is take away 7/15 from the 4. Now you can split the 4 down. 4 can be 3 and 1. And if you take the 7/15 from 1, does it look familiar? Something we did earlier in this lesson, where 1 take away 7/15 must be 8/15, because the 7 and the 8 need to add up to 15. So the whole number we have left is 3, and the fraction we have left is 8/15. Did you get that? Let's have some practice on subtracting some mixed numbers. Have a go, see how you get on, and then I'll quickly go through the working out. Okay, let's go through the working out. So 7 take away 1 is 6. We then need to do 2/5 take away 1/4. So we're looking for a common denominator for 5 and 4, which is 20. 5 goes into 24 times, so multiply 2 by 4 to get 8. So 8/20 is equivalent to 2/5. 4 goes into 25 times, so 5 times the 1 gives us 5/20, which is our equivalence for 1/4. Now we have our common denominator. We can take the 5 away from the 8 to get 3/20. So our answer is 6 and 3/20. The next question. 8 take away 2 is 6. So then we need to do the fractions, where we have to look for a common denominator. So both of 10 and 2 divide into 10. 10 divides into 10 once, so 1 times 7 is 7. So 7/10 is 7/10. We don't have to make it equivalent. 2 goes into 10 5 times, so 5 times 1 is 5. So a half is the same as 5 over 10. Now they're equivalent, we can subtract them and use our common denominator of 10 to get 2 over 10. Now this is an example of where you can simplify this fraction. All of the answers we've had so far have not been able to simplify, but this one does. You can see that 2 divides both into the numerator and the denominator. 2 goes into 2 once, 2 goes into 10 5 times. So 2 over 10 simplified is 1/5. So for all the marks in this question, it's 6 and 1/5. Last question, and the trickiest of the three. We have 6 take away 1 that gives us 5 whole numbers. We then have 1/10 and 3/4 that we need to subtract. So 10 and 4 have 20 as a common denominator. and we're going to subtract the 2. 10 goes into 20 twice, so 1 times 2 gives us 2 over 20 as an equivalence for 1 over 10. 4 goes into 20 5 times, so 3 times 5 is 15, so 15 over 20 is equivalent to 3/4. So again, the number on the left is smaller than the number on the right, so it's 2 take away 15. The denominator is 20. On our number line, if we are at 2 and we need to take away 15, we know there's 2 there, you end up with minus 13. So the result of subtracting our fractions is minus 13. What you have to do then is go back to your whole number of 5 and split it as a 4 and a 1. And then the problem becomes 1 minus 13 over 20. Because this has got a minus sign, we need to take it away from our whole number. So, as we learned before, if you have 1 take away a fraction, then the answer is the difference between the numerator and the denominator. So 7 over 20 is our answer. So what are we left with? Well, we have 4 as our whole number and 7 over 20 as our fraction. So the correct answer is 4 and 7/20. Here's an example from an exam practice paper where they want us to work out 5 3/4 take away 1 1/8. So, from what we've just learned, 5 take away 1 is 4. Do your fractions where you're looking for a common denominator, and 4 and 8 both divide nicely into 8. 4 goes into 8 twice, so multiply the 3 by the 2 to make 6 over 8 equivalent to 3/4. The 1/8 doesn't change, so I've got 6/8, take away the 1/8, leaves me with 5/8. So our whole number is 4 and our fraction part is 5/8. And that concludes the learning outcome to add and subtract quantities using proper and improper fractions and mixed numbers. Let's look at the buzzwords. As we said on a previous video, equivalence is very important indeed. And this is where we can turn a fraction like a half into another fraction like 3 over 6 by multiplying the top and the bottom by the same number. A proper fraction is a normal fraction where the numerator is smaller than the denominator. An improper fraction is where the numerator is bigger than the denominator, and all this means is you have a number larger than 1. And then finally, a mixed number is a whole number with a fraction. If you'd like more practice on anything in this video, please go to Moodle for homework and worksheets on these topics. I hope you enjoyed the video.